The key for the pre-quiz, part 2, chapter 4. Mostly it's just solving logarithms and solving exponentials, and then some application problems that pretty much are written as growth or decay exponentials, which is just basically the interest problem a per. So that's why you'll see at the end of this just a interest problem with a per compound continuously. Okay, so first one, solving exponentials. We can try to rewrite 4 and 12 as the same base, right? We've done that before, but here we can't. So what we can do is we can do the inverse of exponentials, which is logarithms. So I can take the log of both sides, and remember, I can really take the log with any base of both sides. But we really like L, just log, because that is the same as log base 10, and that's the log on your calculator. And you can also take log base e, because log base e is ln, and that's ln on your calculator. Usually you use that type when you have an e as your base. You usually use that ln, but it really doesn't matter here. But you can use any base that you want to, even log base 4, because if you use log base 4 on this problem, when I log both sides, just make sure to log both sides. I have to use base 4 on both sides. But here you can see, once I bring this x, remember the exponent, I use the properties of logarithms, where that exponent now becomes multiplying by the log, and then log base 4 of 4 is 1, right? So that's x equals log base 4 of 12, and then I have to use my logarithm change of base formula that says take the log of the top, which is what I'm taking the log of, over the log of the base. And again, that log right here, this log could be base 10, or it could be ln. I could take ln of 12 over ln of 4. Just make sure on your calculator when you write that out that that it's log, and it'll automatically pop up parenthesis, put in 12. Make sure you close that parenthesis before you hit divided by, and then you can do log parenthesis 4, and then you close out that parenthesis to make sure you get the right answer. So here we go, x equals 1.79-ish, right? So round to the hundredths place. And I'll go ahead and say that on the quiz, round to the nearest at the beginning. Okay, so this one, again, I can't switch base 6 and 4 on the same. So I'm going to log both sides. This time I'm just going to do log base 10. And I got to do it to both sides. So what's nice about these ones are these are both set equal, the bases are set equal to each other. If the bases are not set equal to each other, then you can log everything on the left and everything on the right. It's kind of the same rules, it's just like sometimes when we have this problem, okay, sometimes we want to divide by 2 first, which is fine, but I can't just divide 2 over here and 6 over here, right? I have to divide everything by 2. So if these are if I had, 2 raised to the x minus 3 equals, say, 6, or say 6 raised to x plus 2, I can try to get the logs by itself, or I can take the log of all 3 of these, right? So I'd have to take the negative log of 3 and then equals log of 6. So I'd have to do it to everything, right? So it's kind of nice. It's kind of nice that these bases are already by themselves or set equal to each other. If not, I would have to log, everything, just like I would have to divide everything by 2. Okay, so base 10. Exponents go out in front of the log. They're being multiplied, so put those in parentheses. Anytime you have a binomial or more as an exponent, put that in parentheses when you're use that log property, the power log property. And here, might as well do it on this one automatically. There you go. Okay, so that one I only had one term, so I didn't put it in parentheses. That's why. Okay, this log, I can distribute a log of a number inside the parentheses. Okay, that's true. You can do that. Plus 3 log of 6 equals x log of 4. Okay. So you can take the log of something and distribute, but you cannot distribute a just plain log. So if I had like log of x plus 1, I can't distribute the log to both of them. If it was log 6 of that, then I can go ahead and distribute log 6, but I can't distribute just log. Okay, so those are kind of, because I'm taking the log of what's inside the parentheses. This one, I'm taking the log of 6, and then I'm multiplying it by x plus 3. Alright, now get the x's by itself, so we need, if we can bring this x over, right, and I want to subtract 2 log 6. It's kind of like this. When I have something, sometimes like 2x equals 4, and I'm trying to get x by itself, sometimes we try to subtract 2 and then delete this, so then we get x, right? That's not right. We need to, you need to divide. So the same thing here. I can't just subtract x and that x is gone, right? So I got to subtract x log of 6 on both sides. So I do that on both sides. And here, I cannot subtract these, right? Because this is log of 4, which is, I can't think off the top of my head what that is, nor log of 6. So I can't really subtract them, right? Because I don't know what this number is, and I don't know what this number is. This is not 1x minus 1x. It is whatever log 4 is, x, and log 6 of x. That's what I'm subtracting here. So I can't do that. So I have x log 4 minus x log 6 equals 3 log of 6. Okay, now I can go ahead and undistribute, because look at both these terms. I have an x in it, so I can factor out an x, put an x on the outside. Now I'm only down to 1x, right? So now that I'm down to 1x, and that x is being multiplied by the quantity log 4 minus log 6, which you could combine those if you want to, right? Because whenever we subtract two logs with the same base, we can divide that. So you could rewrite this if you wanted to as log base 10 of 4 over 6 and reduce that fraction. That's fine. I just kind of leave it. So it doesn't really matter however you want to work it. So this is multiplication here. So I get rid of that by dividing by log 4 minus log 6 on both sides. And that's what I'm going to type in my calculator. I'll show you exactly what I'm going to type in my calculator. I'm going to type 3 log 6, and automatically brings up parentheses. Close that off. And you could get it's not needed now on this problem, but if you put your numerator inside parentheses, then you won't get in trouble later when you have some more stuff going on in your numerator than just one term there. Okay, then divided by, hit parentheses, because you want to parenthesis your denominator as well. Hit log, boom, that comes up. You put in 4, close that off, then divide by log, boom, opens up parenthesis, put in 6, close that, and then close your denominator. Okay, if I don't close this one right here, that means it would take 4 and divide it by the log of 6, and then take the log of that, right? But I want to take the log of 4 and then divide that by the log of 6. So that's why those parentheses needed to be in there. Okay, so now we can enter that into my calculator, and I can figure out what this answer is. So then we get x is equal to negative 13.26. We can plug that back in, and that works. Okay. Okay, so here's another one. This time the base is not by itself, so we want to get the base by itself first. So we want to divide both sides by 2. And then our base is now by itself. So now we can go ahead and solve this. Here we want to take the ln of both sides because we have a base of e. So we're going to ln both sides. And so we'll ln of both sides. I'm going to rewrite it for those people that are just looking at the answer key. Okay, so now we can go ahead and take our exponent, move that out front, so we get 5x, and because again that is a binomial, I want to rewrite that in parentheses so that I know I need to distribute. Well, here I don't need to distribute, right? Because what does ln of e equal? It equals 1, so I just get 5x. That's why these ones with e base e's are really nice. Actually pretty easy. Then we subtract 2 on both sides. Subtract 2. Ooh, so we get 5x equals ln of 4, then minus 2. So you might want to put this in parentheses, you know, to let your calculator, especially on your calculator, to let you know you're going to do ln of 4 and then you're going to subtract 2. Not because if I didn't put parentheses and I put that on my calculator, it would say I'm going to take the ln of 4 minus 2. So it would actually take the ln of 2, not the ln of 4. Then I want to divide that by 5. So x is equal to ln of 4, then I'm going to subtract 2, and then I'm going to divide by 5. So x is equal to negative 0.12. And plug that back in. Remember, when you plug these ones back in, because I rounded, right? Because I rounded, it's not going to be exactly correct, but it's going to be pretty close. If you wanted to do exact, whatever you get in here on your calculator, then that's what you would put back into the very beginning. Like try to keep that in your calculator. Take that number, times it by 5, then add 2 to it, and then raise it, push the E button, push your answer, enter, then times that by 2, and it'll equal 8. Okay, this bottom one, okay, bases are not the same, can't turn them into each other, but bases are kind of set equal to each other. So that means that I can go ahead and ln both sides or log both sides. Again, it doesn't matter. I could log base 6 of both sides or log base 3 of both sides. We'll just do base 10. And then we can take those exponents there. Oops, don't forget the log. Okay, now this is definitely a harder one because they're both binomials, right? So those are going to go out front of the logs using make sure you put them in parentheses, because those are the power property of logarithms. It says we can take the exponent of the log and bring it and multiply by the log. 3. Okay, then we can distribute, so we get x log base 6 minus 3 log. Is this the same exact problem as before? No? Almost, huh? 4x log 3. The left side looks similar. I think it was a plus, though. X plus 3. Okay, distracting myself. 1 log 3. Okay, and then I want to put my x's together and put my regular numbers together. So let's add this. Add 3 log. Again, I cannot add these two because that's log 3, and this is log 2, or log 6. So I can't add those and get 4 log 18 or something. I don't know what you would think you would get, but you can't do that. So I'll do it one step at a time for those people that are just looking at the notes. So I'll pause it. Okay, then we'll go ahead and subtract this 4x on both sides. Again, I can't subtract those. Okay, so that's what it looks like. Then we're going to factor out the x on the left. You could combine these, right? I could write that 3 as an exponent, right? And then I could go ahead and, since I'm adding 2 logs to the same base, I could multiply those, but I would have to take 6 to the 3rd first and then multiply it by 3, right? Because that 3 is an exponent. So that's 6 times 6 times 6. So whatever 36 times 6 is. And then I would times that by another 3. So actually it's really 6 to the... oh, not by 3, sorry. I would multiply by 3. So you could join that together on the right there. On the left, we can factor out an x, right? So we pull out an x. What gets left is log base 6 minus 4 log base 3 equals 3 log 6 plus log 3. And then we can divide. And again, you could join these two together now if you wanted to. You could use the properties of logarithm. And you would have, what, like 6? You'd have 6 over 3 raised to the 4th with log base 10. But I am going to keep them separate. I guess probably in your calculator would be less typing maybe. So in my calculator, what I'm going to do is I want to type parenthesis to keep my numerator up there. 3 log, it'll hit that parenthesis, close off that one, plus log, that will come up, put in 3, close that off, close off your numerator, then hit the divided by sign, and then hit parenthesis for your denominator, log, close off that parenthesis, minus 4 log, close off that parenthesis, close off your denominator. And that's how it should look like in your calculator. So it is x equal negative 2.49-ish. Again, so if you test that, it should come out just fine. And again, it might be a little off because we rounded to the hundredths place here. Alright, so these ones are maybe a little bit tricky, you know, because here we don't have one base equaling another base, right? We have some more. The key thing in here is this multiplication. because that's multiplying, we follow our rules of multiplying with the same base, right? Because we have the same base e. So when we have the same base, we add exponents. So this is e raised to the 6x plus x. Because when we have the same base, we're multiplying by the same base, we add exponents, right? And we can go ahead and add those because there's both x's, right? So we get e to the 7x equals e to the 21st. Now I don't even have to log both sides because my bases are the same. So I can take what the logs are and set them equal to each other. And then say x equals 3, right? And we can plug that back in and check. This one's easier to check, right? Because all I have to do is make sure my... you can multiply it all out on your calculator using the E button, but that's okay. Well, I mean, sure, do it. See if you get the right answer. So 3, so that'd be 6 times 3, and then another 3 equals 21. We're timesing here. So 18, e raised to the 18 times e to the 3rd equals to the 21. And remember, when we multiply by the same base, we add exponents, so I'm not actually multiplying this out, right? And so that is 18 plus 3, which equals e to the 21. So it is correct. So those are exponentials. Okay, so here's now it's logarithms. So like I said, you cannot distribute this log base 2. Even though this looks like when I'm taking the log of 2, this is a base 2. I can't distribute the log to both of these, okay? I am taking the log of the quantity x squared minus 8, okay? So I cannot distribute the log. So don't even think about doing that. Okay, now once the log is by itself on one side, then we can switch to exponential form. Okay, so 2 raised to 3 equals x squared minus 8. Now, when you have an x squared in here, you got to think quadratic, right? This is 8 squared minus 8. We add 8 to both sides. Add 8 to both sides. We get 16. So it's a quadratic. One way to solve quadratics, whenever we just have an x squared and a constant, we can just square root both sides. And when we square root, we have plus or minus. So we get x is equal to plus or minus 4. Whenever you have logs, you need to plug those back in and check them to make sure that they are correct. But you are squaring your x, so it's automatically going to be positive. So negative 4 or positive 4, I'd get 16, and 16 minus 8 is 8, and 2 raised to what is 8? That'd be 3, right? So it does work. So make sure you always go back in and check your logs to make sure that they do work. Okay, so somewhere I forgot to push record, so I don't know where I went. So I'm just going to start with B again. Here, since I have 2 logs, I need to combine them. It's a plus sign, so that means I'm multiplying what I'm taking the log of. Right, so I'm going to multiply these, keep the base the same, log 3, multiply those. You're going to have to FOIL that out, and you get a quadratic, and then you can switch to exponential. And then we go ahead and simplify. We get 9. Then we're going to subtract both sides. So we get this quadratic at 2x squared minus 5x minus 12. You can try cab on it. What are the factors of 24 that subtract to 5? So you get like 12 and 2. Can't do that. 8 and 3. 8 and 3. So there we go. So 8 and 3 and a positive 8. Or say our negative 8 and a positive 3 will get me there. Okay. So we're good there. Then we divide those by our a, which is 2. So let's go ahead and just write it out for now. So we get x minus 8 times x plus 3. Then we divide by our a. And we can actually leave it like that because we're solving. And so that means x would equal 4. And x would equal negative 3 halves. Again, we need to check, make sure these both work, that we don't get any negatives. We have a negative 3 halves, and so when I put that in here, I know that this negative is not going to work, right? So that one's not going to work. So 4, 8 is 2, and 4 is 1 is 0, and 2 plus 0 is 2. So this one does indeed work. Okay, looking at this one, we got ln. Again, we can combine these logs by multiplying, keep them under ln. And then we can go ahead and add our exponents here. We can switch these to exponential. My base is e. then we can go ahead and do this button, go ahead and press this on the calculator, and well, I guess we could take the fifth root first. So you can take the fifth root of both sides. And I could do that on my calculator, which is, I could do that on my calculator, or I can do e to the 6 over 5 on my calculator, and that will give me x. So it is approximately 3.32. Okay, and you can check that. Alright, the last two are the application ones. One's most used is exponential decay. You can use the growth one as too. That's mostly done. Exponential growth is done with investment problems or interest problems, like the one on number 4 here. So this type, we're trying to find the amount after 12 days, where t is in days. So make sure you're paying attention. T is in days here. So we're just going to go ahead and enter this into our calculator just like this. When you press that E button, boom, this will pop up. I do negative 0.03, and you can do multiplied by 12. I'm going to press that just like that in my calculator, and it's going to give me the answer. So a to the 12 is equal to, and because I'm typing in 12, a lot of people are probably confused here with this a of t. It's just saying that t is your variable, right? And because normally you just have it just a equals. So it could just be a equals is fine. But a lot of people are going to get the answer and then divide it by 12, because when they see parentheses, you know, it's automatically multiplication, right? It's not a of 12, it's a times 12. It's not a times 12, it's a of 12. Right, and that's going to give us our answer. So don't divide by 12 here when you get your answer. So you get approximately 279 point, let's see, 0.07. So that's approximately, that's how much amount of radioactivity material you'll have left in grams. Now how much, find the half-life of the material, right? So that means half its life, or half the weight, oops, which is 200. Right, and you can divide by both sides, because they were actually finding how many days it takes. So if you divide by 400 on both sides, you'd get a half, right? That's the whole point of finding a half-life. So we have 1/2 equals E raised to the negative 0.03 t. Now we can do ln of both sides. So like ln 1/2 equals ln of E 0.03 t, and then this ln will be equal to 1, so we bring that down in front, right? So this comes down in front, and then ln of E equals 1. And then so ln of 1/2 divided by 0.03 equals t. So do this on our calculator. So t is going to equal 23 days. Okay, the next one is dealing with insurance. So here's big spiel about investing. Smart to invest young, especially. It's not too early to invest in your retirement, because even if you don't have very much, over time it'll start occurring interest, and then it'll start the interest that you make. Even that will occur interest. So even investing a small amount over a long period of time, you get a bigger return in the end. The traditional IRA is before your taxes come out, that money is invested in your retirement fund, okay, and then when you retire, that money is then taxed, right? So that's kind of what this first paragraph is saying. There's different kinds of IRAs. There's called like a Roth IRA, which after you're taxed federally, then you take your money and then you invest it. So it's already been taxed, so that means when you get out, when you retire, it's not taxed, right? And you know, that's why they have financial planners that figure this all out for you, right? So we're supposing that we're investing $5,000, and we're going to invest that at 4%, which is really low. And actually, currently the rates are really high. So you're getting like even over 10 right now. So that's kind of a really small rate. So you're going to invest $5,000, and then you're in the 25% tax bracket. So that means after you make all your money and you turn 60 and withdraw, you're going to have to take 25% of that, right? So that's why it says pay after taxes at 60, and you're going to start investing at 25. Okay, so we'll invest at 25, $5,000. And it is continual, right? Annual interest of 4%. And we're investing $5,000. And then you're going to use E, because this is an exponential growth. And then my rate is 0.04 times how many years, which is 35. So that's the amount in the count. And then we have to pay 25% tax on that. So that means I only get to keep 75%. So I want to multiply my A by 75, and that's going to give me my answer. So you might have a question of why I'm using the A PERT on this one. And that's because we're talking about using exponentials, and the formula is, you know, y equals y sub 0 equals e raised to our kt, and k is our rate, which is 0.4, and y sub 0 is how much I invest originally. And so, it says right here, compound continuously. Keyword there too. Okay, and so we'll go multiply this out, and we get $15,207 around there. Okay, and now we want to suppose that we, instead of depositing an IRA, we're gonna tax the amount we put in beforehand, and then also that would affect our interest rate, or sorry, our amount that we put in. So we're going to take 75% of 50,000, or sorry, 5,000, and 75% of 4%. So we want to figure out how much if we tax before and then put our money in, so then when we make it out we don't get taxed as much. So we're going to take 75% of 5,000 and 75% of 4%, which is 3%, and 75% of 5,000 is 3750, and 0.03% for 35 years. And you can see this is definitely not going to give as much as this one did, but then we took our taxes out, right? That's why we got 15,207. And now we're investing a little bit less at a little lower rate, but we don't have to have taxes at the end, right? So now I just get my answer as A. I don't get a minus 25% of that, right? So I get to keep the full thing after I do this. So here it is only $10,716. So I don't get as much out. So so you might think, hey, it's better to just put in and then take out later. But that's probably something to talk to a financial advisor about before you do it on. Now, how much money additionally you need to earn from the IRA? How much will you earn more? You know, basically what's the difference between these, right? Is all it's asking. How much money will you earn additionally if you put in the IRA versus being taxed first and then put into it? And that's just $4,491. Okay, so that's it for the pre-quiz.